This video presents a joint experiment between 5G Picture and Metro Hall projects on Metro Optical Transport Solutions. 5G Picture provides converged fronthaul and backhaul infrastructure and develops the disaggregated RAN where hardware and software components are distributed along the network. The TOPOLOGY node developed by University of Bristol combines packet switching and time slot assignment within WDM channels, which supports low latency network slicing in transport metro area. Metro Hall focuses on new optical metro infrastructure where nodes provide both optical flexible connectivity and storage and computing capabilities. Team has developed a low-cost 3-degree ROADM to provide optical connectivity between Metro Hall nodes in the metro transport network. The 5G Picture TOPOLOGY and the Metro Hall ROADM can be combined to provide end-to-end layer 2 services on a metro optical network. The integration is possible not only at the data plane layer but also at the control plane, as both solutions support TSDM paradigm with NetConf Eucnc prototype controllers. The demo shows the end-to-end provisioning of a layer 2 VLAN service between TOPOLOGY nodes connected through ROADMs managed by the open source ONOS controller. The data plane was set up in Team's Turing labs, while the control plane was running at the University of Bristol. The live demo was held in Valencia during the Eucnc 2019 conference. First step is getting the nodes and links topology before sending it to ONOS using the ONOS REST API. We use the Postman app to send REST commands to ONOS. Going live on the ONOS GUI, we can see that nodes are managed and no links are available. We send topology information via REST, and on the GUI we can see links appearing. We can check also the links list where we find links between TOPOLOGY and ROADMs and links between ROADMs. The traffic is not yet running. We have no optical intents or flows as only topology information has been sent. After setting the topology, we could run path computation triggered by a service request. This part has not yet been developed, so we build a JSON file which describes the path between device ports. Now, with the explicit path, we can establish the end-to-end connection. First, we cross-connect a 10 gigabit Ethernet VLAN service to one OCH port on TOPOLOgy using the ONOS CLI command. Then, we activate optical cross connections inside ROADMs, sending an optical intent creation request to ONOS via the REST API, which contains the explicit path info. Let's see the live service activation. First, we activate TOPOLOgy nodes to send traffic through the selected OCH port, in this case the 10101 port, with an ONOS CLI command. The TOPOLOgy nodes send a RPC reply to acknowledge the request. The traffic is not yet running because the ROADMs are not yet properly configured. Now, we send an optical intent request containing the explicit path and the information about optical frequency and the slot width of the OCH channel via the ONOS REST API. We see in the ROADM console that optical cross connections are set and the traffic starts to flow, visible via the analyzer. We can also check on the ONOS GUI that the intent is configured both in the intent menu and on the topology view. In this last part, we covered the link recovery from a failure. The failure detection mechanism is not yet implemented. However, we have some building blocks to potentially allow for this. Firstly, We can use the ONOS CLI command to swap the traffic from one OCH port to the second one available on TSON. Then we can request another optical intent to deliver the swap traffic via a protected path. Let's see how this works live. The traffic is running. Let's suppose that a failure detection mechanism is in place that triggers the swap command on TSON. We activate TSON OCH port 20101. The traffic is dropped because ROADMs are not set to support the new OCH. The new optical channel has a central frequency of 193.4 THz, so we must request the creation of the related optical intent. We send the usual request via REST, and we can see ROADM creates the new cross connections, the intent creation on the ONOS GUI, and the traffic recovery on the analyzer. Again, we can check the optical intent creation also on the topology view. That's all from the 5G Picture and Metro Hall team. Thank you for watching.